Welcome back to AI Takeover channel. This is gonna blow your mind. Imagine a vast, intricate web humming with energy. Each connection in this web crackles with information. This is a glimpse into the world of artificial intelligence, specifically neural networks. These networks are changing how we interact with technology and the world around us. They power our smartphones, our cars, and even our homes. Neural networks are revolutionizing industries from healthcare to finance. They are helping us solve complex problems that have long baffled human minds. But what exactly are these mysterious networks? How do they work? And what makes them so powerful? Neural networks, as their name suggests, draw inspiration from the most complex organ we know, the human brain. This intricate and powerful organ is responsible for everything we think, feel, and do. It processes vast amounts of information every second, allowing us to navigate our complex world. The brain consists of billions of interconnected cells called neurons. These neurons form an incredibly dense network, communicating with each other through electrical and chemical signals. Each neuron receives signals from others through synapses, processes these signals, and transmits its own signal to other neurons. This constant exchange of information is what enables us to think, learn, and remember. This intricate network of communication forms the basis of our thoughts, memories, and actions. It is the foundation of our consciousness and identity. Artificial neural networks mimic this structure. They are designed to replicate the way our brain processes information, making them incredibly powerful tools in the field of artificial intelligence. They consist of artificial neurons, also known as nodes, interconnected in a similar way to neurons in the brain. These nodes work together to process information and make decisions. These nodes are organized in layers, much like the different regions of the brain specialize in specific functions. Each layer in a neural network is responsible for different aspects of processing, allowing for complex and nuanced understanding of data. A typical neural network has three types of layers: an input layer, one or more hidden layers, which can be numerous depending on the complexity of the network, and an output layer. The input layer receives the raw data, such as an image or a sound. This is the starting point where the network begins its work. This data is then passed through the hidden layers, where the magic happens. These layers perform complex transformations on the data. Each connection between nodes has a weight associated with it, which determines the strength of the connection. These weights are adjusted during training to improve accuracy. Think of a detective solving a case. They gather clues, analyze them, and piece together the story, and use their knowledge to connect the dots. Each clue is like a piece of data that needs to be interpreted. Similarly, each hidden layer in a neural network extracts features and patterns from the data, much like a detective looking for clues. These features are then used to make predictions or decisions. But how do neural networks learn to solve problems? This question has intrigued scientists and researchers for decades. They learn through a process called training, which is fundamental to their development and functionality. During training, the network is fed a large dataset and adjusts the weights of its connections to minimize errors in its predictions. This iterative process is crucial for the network to improve its accuracy. This is akin to trial and error, where the network learns from its mistakes and improves its performance over time. Just like a child learning to ride a bike, it gets better with practice. Neural networks are revolutionizing our world. They power virtual assistants, translate languages, recognize faces, and even diagnose diseases. Their applications are vast and continually expanding. As we delve deeper into the realm of AI, understanding neural networks becomes crucial. They are the backbone of many modern technologies. These networks are not merely tools, but a testament to human ingenuity, showcasing our ability to replicate complex cognitive functions, mimicking the very essence of our intelligence to create a future brimming with possibilities. The potential is limitless, and the journey has just begun. Don't forget to like and subscribe.